A measure of central tendency tells us where the middle of the data is, but there's more than one way to look at a middle of the data, and each of them have important aspects. The most common one that you probably know is called the mean. The mean is your arithmetic average, but we're also going to look at the mode and the median. Now, you may have looked at these topics way back in grade 9 when you did some statistics, but you might have forgotten them completely. They're not hard concepts. The first one that we're going to look at is the mode. The mode is the value that happens the most often. Okay? Sometimes that's a very important central tendency to know. For example, you go to work for a company. They say, come work for our company. You're like, why should I work for your company? Well, the average salary is $200,000 a year. You want to work for that company. So you're like, oh yeah, I want to work for that company. You get to the company, you sign your contract, and your average salary is $10,000 a year. You're like, what? Or not your average, your salary is $10,000 a year. You're like, what? I thought you said the average salary of the company was $200,000. They said it is, right? We have 100 or 1,000 people all making $10,000 a year, and our CEO makes $2 million a year, right? And so in that case, knowing the average isn't very helpful, because you've got one person making a ton of money. That skews the average higher, but everybody else isn't making peanuts. But if they told you that, oh yeah, by the way, there's 200 people working at this company, 199 of them make $10,000 a year and one person makes $2 million. If they told you the mode, what happens the most is most people make $10,000 a year, you'd be like, yeah, no, I'm going to go to a different place. So it could be helpful. Now, if there are sometimes something that happens more than once, we've got the word bimodal in there or multimodal. You could have that 10 people make 10,000, 10 people make 20,000, one person makes $1 million. Well, then that would be bimodal because you have two values that both happen 10 times. And if everything is only once, we say there's no mode. Find the mode for the following data. So we just have to find which value occurs the most times. Now the data, the way that it's listed right there, isn't very helpful. If we rewrote it from least to greatest, it might be a little bit easier to see which one occurs the most. And after writing it out, what's the mode? Which one happens the most? 12. Last class, we were introduced to frequency tables. A reminder about the frequency table. Here is the value. Here is how many times it happened. So we've got mark and frequency. Maybe we had a multiple choice test out of 10. Then those percentages would make sense. 12 people got 5 out of 10. 10 people got 6 out of 10. 10 people got 7 out of 10. And 5 people got 8 out of 10. Which is the mode in this case? Which happens the most? The 50. So we have to know that these are our scores. The frequency itself telling us how many times it happens. In the next frequency table, things are grouped together. We've got weights between 60 and 70, weights between 70 and 80, 80 and 90, 90 and 100. Here we would say we have a modal class because it's grouped together, and our modal class was the 70 to 80 because it happens the most times at 6. So that mode from that grouped frequency table is called a modal class. I find the easiest way to remember the definition of mode is it happens the most. Mode, most. Yeah? Could work. The mean. This is your mathematical or arithmetic average. This is the average that you're most used to using. How you calculate your school average, how you calculate your average on a test. You add up how many you got out of the total number there was. Okay? So if you had 3 tests and you got 60 on all 3 tests, what's your average? 60. Of course, probably didn't have to do much math for that one. But you could have done 60 plus 60 plus 60, 3 tests, 180, divide by how many you had, which was 3, to get your average to be 60. So now we're going to get into some fancy formulas. Okay? We get a nice new symbol for the average, for the mean. This is the Greek letter mu. It's one of my favorite Greek letters because when you write it like that, okay, it looks pretty. I like writing pretty letters. It's called mu, and it looks like an M and a U at the same time. I think that's pretty cool. Okay, so the average, mu, is, what does this symbol mean? Sum. The sum of all the items that you have divided by n, the number of that you had in total. So if you had 15 test scores, it would add up all 15 of those test scores, but then divide by 15. So some notations. Mu is used for a population mean, x with a bar over top of it, a sample mean. In the level of statistics that we do, we don't really get too worried about that notation. Higher level statistics, they're like, oh, you took a sample, so then you have to use the x with the bar over top of it. Oh, you counted the whole population in, then you should use the symbol for mu. There's our IB marks, 1 to 7. There's our frequency. The average was 4.6. Find K. Then B, write down the mode. What I'm going to often do for questions in class is I'm going to give you an opportunity to start them on your own. Obviously, if I do all the math for you, you'll just sit there and nod your head and you'll be like, yes, that makes sense. But what you really want to check is, do you have the right idea to start? What would you do in this situation? And then you can start it. Actually, the idea is probably more important than all the numerical stuff. Like, I know you guys can add and multiply. And I know that you guys can still make mistakes adding and multiplying. I still do. But if you have the idea right, that's the key thing. With your setup here, first of all, we know the average is 4.6. The mark of 1 happens 0 times. The mark of 4 happens twice. The mark of 6 happens, the mark of 3 happens 6 times. The mark of 4 happens k times all the way through. The total number that we have, well, all these other numbers add up to 30, but you don't know what k is, so your total number is 30 plus k. If I add all those things on the top, I get 144 plus 4k. On the bottom, I still have 30 plus k. I have an equation with one variable to solve. How do we solve for k? Well, I mean, if this is, and this is something about the IB course that you have to make decisions. The numbers in this one look like it would be a calculator question. So at this point, I'm still working algebraically because it's not too bad. If I multiply both sides by 30 plus k and distribute on the left, I can isolate k and divide and find out that k is 10. If in solving for k you got a decimal, something should have made you go, this seems wrong because it's supposed to be a frequency. You can't have 3 1/4 people get a mark of 6. It should be a whole number. So understanding the context of the question tells us that the k value should be a whole number. Here we got our k value of 10. If we go back to the entire page now, if k is 10, our mode is going to be 4. Because now we know that that one occurs the most times. Now, this one did very well to solve algebraically. But one of the things that's going to be different in this course compared to your pre-calculus courses before is if you have technology, you always have to try to make a decision. Should I solve this algebraically at this point? Or should I use my calculator? And one of the ways that you could use your calculator in this one, go to my calculator here, I have 4.6 on one side of my equation, and on the other side of my equation was 144 plus 4k, which I'm going to use x, over 30 plus x. Did I type anything in wrong? I think that's right. If I graph this, 4.6 is a straight line. And there's my second one. What is the solution is where they intersect. Okay, I'm going to see second, calculate number 5. Does it show up where they intersect? First curve, second curve. Guess. Yes. It intersects at 10. So I get my solution from my graphing calculator. At this point in the question, you have to make the decision. Would it be faster for me to type it into my calculator and get the answer that way? Or is it faster for me to do the algebraic solution? In this case, they're probably pretty close. But one of the things that this course wants you to start thinking about is, what are all the options available to me? Because if I can solve it faster with an option that's available to me, I should probably do that. And that's something that going out into a workforce, right? Sometimes you have restrictions, sometimes you don't. How do you use what you have available to your best ability? And that's what they're trying to teach you in this course. 30 plus k is the n value because that's how many students there were, and that comes from the frequency. If I add up all the frequency numbers, I'm going to get 30, but I don't know what k is. So I know there's 30 plus k students. Number of students in this case. Because when you're trying to find the average mark per student, you would divide by the number of students. So here is the longest way we could calculate the mean. If you had this example 2 with the length and the frequency, we could use our data to say, I need to add up everything. 10 happens 6 times, so that's going to add up to 60. 15 happens 12 times, that's going to add up to 180. 20 happens 13 times, that adds up to 260, and 25 happens 4 times, adding up to 100. The total of all of those together equals 600. I think you have no problem with this 600, but what I want you to focus on is the notation. Again, understanding where the notation and what everything stands for is important. First of all, the big sigma sign, that means sum. Did we add things up? Yes, we did. This plus this plus this plus this was 600. What's happening inside? F with a little I, X with a little I. The little subscript I is just saying, do each of them first value times first frequency, second value times second frequency, third value times third frequency, fourth value times fourth frequency. Here the F is the frequency, the X is the value. Here we're adding up all the frequencies. Adding up all the frequencies, 6 plus 12 plus 13 plus 4, the little I again is first one, then second one, then third one, then fourth one. So that little index I is just to tell you that you should do each one separately until you've done them all. What's our average? Well, it's going to be the 600 divided by the 35. Sorry, some of these things are a little bit small here. I'll make them neater. This is I equals 1. And so some more things that sometimes happen in a sigma formula. Again, if you don't know what's happening, that formula there can look very, very scary. So again, we need to break it down. What do all of these things mean? Okay, sigma means sum. We're adding up frequencies. And we're adding up the frequencies starting with number 1. That's what the I equals 1 on the bottom is a starting point. And going up to n. N is the number of things you had. In this case, we have 4 of them. We're adding up frequency 1, frequency 2, frequency 3, and frequency 4. What another thing that the IB course will do is it will ask you to understand how it works. How does an average work? Do you understand that? They will try to be creative, to think of the most creative way to check your understanding. This question, finding the mean, isn't very creative to check if you know what it means. We'll get to some examples we're going to do an activity where it's really going to check, do you understand what it means? Okay? Then once they're convinced that they've had enough questions that force you to understand what it means, then they're like, good, I'm glad you understand what it means. Now let's use technology to figure this out the fastest. You know how to add, you know how to multiply. Why waste your time doing that yourself when there's something faster that can do it? So we can go to our calculator, we can go to our stat and edit. I'm going to clear down to get rid of the data that I have in there, clear down, and enter in these values that were given to us. So the lengths were 10, 15, 20, and 25. And the frequencies were 6, 12, 13, and 4. Now that I have my data in my calculator, go Stat, over to Calculate, 1 var stats. Again, mine comes up with list 1 and list 2 here. Yours, you might have to write list 1, comma, list 2. When you go to Calculate, a couple of things show up, and you start to realize, oh, they gave us the sum of x, this 600, in case you wanted that part of that formula. They gave us n is 35, in case you wanted that part of that formula. We've got our average to 3 sig figs at 17.1. That's a lot quicker than doing all of this by hand and drawing that chart. Okay. Again, there's that formula with all of the information. Okay. When data is grouped, we can estimate the mean by assuming that all the data is evenly spread, so you're always taking the middle of the group. Question?
What happens when you get up past like the hundreds and you have like 4-digit numbers, or you need 3 sig figs?
Then you would go to scientific notation. So if you look at that sig fig item that we had before, and you'd say, my answer was, you have 2 options to change this to 3 sig figs. Option number 1, 3.74 times 10 to the 4. Right? Or the zeros at the end are not significant. So this would be 3 sig figs. Personally, you're going to find that the scientific notation is going to be easier for you than the zero stuff. Okay? Is it in science? I think sometimes in science they have stuff like that. You ever seen that? Where that supposedly has 3 sig figs because you have the decimal written. In math, it isn't that way. If 120 has 2 significant figures because that 0 isn't significant. But if you're like, I want the 0 to be significant, then 1.20 times 10 squared in scientific notation would be 3 sig figs. And the nice thing about 3 sig figs, you've got that sheet at the beginning, which hopefully you've looked at, gives you some ideas. But if we run into situations like this, we can talk about them and figure them out as we go. So we're going to estimate the mean for the following data. Filling in this chart. We can write down the frequencies. I'll get you to the middle. Again, when it's grouped, we assume it's evenly spread. So the average of all the data points between 60 and 70 would be 65. Figure out all those middles, add up everything, and calculate the mean. I'll save you a little bit of time here. If you're looking at this later, that F times N, that's frequency times the midpoint. We had 3 of them. Average was 65, so that adds up to, that isn't right. That number's, 95. Yeah, that 4, I don't know where. 195. Yeah, look at that. And is my total number then off too? Probably. Sorry for saving you time. minus 300. That's good. And then you could just take your total divided by how many you have to get your mean, which isn't quite right here. So as you're filling in that chart, I would like you to try example 4, which is more of a do you understand the meaning that's going along with this? And if you finish that early, you can work ahead on the next examples as well. What is the actual mean for this one? Has anyone finished calculating it? What did you say it added up to? 1580? And then 1580 divided by 20 is equal to 76? 79? Yes. Now, don't need to go to 3 sig figs here. Why? Because it's an exact number. Okay? But did we use exact numbers, or did we kind of use an estimate because we were using the midpoints? So the approximation sign would make sense to use because we're using an estimate as we're going through. We're estimating the mean, like what's the average. Why do we have the squiggle brackets? Because we're assuming by choosing the midpoint that it's perfectly stretched out. If the frequency between 60 and 70, if all 3 of those people got 68, well, their average actually would be 68, but we're using 65. If things didn't go right for 4, we can ask some questions. Okay, so find the mean number. Well, you had the total. Again, you had to know what the notation meant with the sigma x to say that's what all the things added up. There was 45 students, so that made 49.6. Then 2 new students came into the class. And they did their experiments quickly. That dropped the average down to 48.9. Okay, you can check how you did on number 5. Or you can check how I did in case I made another adding mistake. And again, after 5, it talks about showing this formula again, understanding what each of the things mean with the frequency. And now we get into some practical questions that you guys always ask. What do I need to get on my next test? All right, check your setup on this one. We introduced the variable x or any other one here to say I don't know what that score is on that last one. I changed my percentages to decimals. You could have kept it out of 100. That's fine as well. Okay? Then We have 6 tests now, and now it's a matter of just working through the algebra. Things are not looking good for his 80% average at this moment. All right, set up for this one. There are 9 months from January to September, 3 months from October to December. So 9 months had 630, 3 months had 810. 12 months in total. Does that setup make sense?
Like I gather it was
Right, but if you think, if the mean number of accidents per month from January to September was 630, that's like having 630 per each of those months, or 639 times. Does that make sense?
Yeah.
And then 810. How many people thought there was 630 in total, right, from January to September? And 810 in total from October to December. So again, the importance of trying it first on your own is realizing, oh, how did I misread that? Because the math itself isn't that hard. It's the understanding of the words and the context that becomes important. And then after this, it's just a matter of doing the calculation. 675 accidents per month. What happens in October to December? Snow. I mean, there's snow in January, but usually people smarten up by January. So they're like, oh yeah, it's slippery. I should slow down. But every time that first snow, setting this one up, we know that all the men have a height of 1.79. There's 72 of them, 28 women. So the average height to 3 sig figs, 1.74 meters. So the last type of central tendency that we look at is called the median. The median is the value in the middle. In order to find the value in the middle, it is helpful to write things in order from smallest to biggest. So in this case, we have 5, then 7, then 9, then 9, then 2 11s, then 15, then 16, then 23. Number one easy thing to do when writing numbers in order from another list is to miss one or to write one too many times. So one of the things that I do as a check is like 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers. Now when you have 9 numbers, there is one number that appears in the middle. 4 to the left of it, 4 to the right of it, 11's right in the middle, 11 is our median. But in our second example, and I'm going to write them out in order here, so we've got 17, 22, 28, 30, 50, 54, 1, 2, 3, 4, 5, 6. There's no number right in the middle. If I choose 30, there's 3 to the left, 2 to the right. If I choose 28, there's 2 to the left, 3 to the right. So in this case, the median becomes the average of the middle 2 values. How do we find an average? You could add those 2 up and divide by 2, or maybe you can just look at it and say, I know the average between 28 and 30. Our median is 29. So when you have an odd number in your data set, There will always be a middle value. When you have an even number, it'll always be an average of the two. Okay? If I have 9 things, my median is the 5th one. If I had 31 things, which would be my median? 16. Okay? What happens if I had 111? How can we find out which one it is? That's the median. It's 56. How do we find that? Well, we can have a little bit the position of the median is always however number that you have. Here I have 9. Add 1 to it and divide by 2. So if you have 9 things, add 1, you get 10, divide by 2. Your position would be the 5th one. If you had 13, add 1, 14, position will be the 7th one. It even works when you have an even number. I have 6 items. If I add 1, I get 7. 7 divided by 2 is 3.5. It's like, oh, I have to take the average of my 3rd and my 4th one to be the median, to be 3.5. So here's your problem solving, and I want you to look at examples 2, 3, 4, and 5 for next class. Have them ready. We'll just quickly start class by going over them, but they get into a little bit more problem solving. We've got 4 numbers, P, Q, R, and S. The average of them is 8. The mode is 7. The median is 7. The range and the range is the difference between the smallest and biggest. The range is 8. Can you find all 4 numbers so that all of those things work? It's a little puzzle.